Okay, so welcome back. Today we want to look at. Let me put that up for a second. So basically, today we want to look at the following. I've got on this off and fix that quickly. So today, basically, we're going to be talking about indices, okay, powers of numbers, and then for indices, powers of numbers, what we want to look at will be how to understand them, the simple way to solve them when they are presented to us, and then how to go about any kind of question that is given to us. Okay, sorry for the feedback. So without wasting time, let's bring it to action. So some books will write powers of numbers as indices. Some books will also say powers of natural numbers. Okay, they all mean the same thing. So indices, powers of natural numbers. Okay, so basically we're just going to take, I'm just going to explain the whole concept. It has rules, okay? So the basic rule, I think over the week or the past month, we've been looking at certain questions that requires that we use indices to solve. Now, certain questions that require that we use indices to solve, an example will be change of subject, where when you're done getting rid of the decimals in your fractions or your decimals, you then move, when you move the decimals, then you have 10 over raised to the power. So all those things helps you when it comes to powers of numbers. Okay, so without wasting time, let's look at the first rule. The first rule, rule 1, we want to say that if I have a raised to the power x times a raised to the power y, once we've established that this is the base number, we've established that the base numbers are the same. Okay, so this is a base number, this is the power. Okay, so you'll be hearing me make reference to this. Okay, so once the powers are the same, what it means, once the base numbers are the same, what it means is that the powers, something will also happen to them. And then once the base numbers are the same, it means we can write them as a single entity. Okay, we are not going to repeat the AA again. Now there's one thing we need to take note of, which is the operation between what? The two base numbers. Okay, this is definitely the foundation. We're going deep into complex powers of numbers and all that. Okay, so having that, the operation is also very important. Okay, now the main operations we'll be dealing with will be multiplication and division. Okay, so multiplication and division. Division can also be in form of a fraction bar. Okay, so whichever one we get, we should be able to work with it. Now let's carefully analyze this. Once the base numbers are the same, what do I mean by the base numbers? When the a, this is the base number, the number that is raised to a power, when it's the same as the one multiplying it or dividing it, in which case we are going to look at the powers should add if the operation between them is multiplication. So it basically means that this is going to end up being the power being written once, the base number being written once, and then the powers will go ahead and then add. Are we okay? So that's the first example, or the first rule. The second rule I want us to look at is, let me change this. Base numbers being the same, but this time the operation sign is division. Okay, with this one, just like because the operation sign here was multiplication, this time around the operation sign is division, so the powers are going to subtract. This rule is very, very important. It's going to help us answer certain questions. Okay, it's going to help us answer certain questions. So our very first example, which is relating to this rule, will be find 2 squared times 2 raised to the power 3 or 2 raised to the power cube divided by 2 raised to the power 4. There are two ways to solve this. You can solve this using the class 1 method, okay? Where we know that when I have a raised to the power a is equal to a times a, we can apply the same principle and use it to solve this, okay? So we'll do that later, but applying the rule that I just explained here will mean that we have multiplication here and then we have division here. And then the base number is the same throughout, okay? So we can go ahead and rewrite this, but I would prefer to rewrite this with a fraction bar. Then again, you can ignore the fraction bar and then solve it as you see it, applying the one we have written on the blackboard. So quickly, let's look at it. We have the base numbers being the same, so we write it just once, and then realize that there's multiplication here. So it means the power between these two powers will multiply, so 3. And then we have what? Division here. So the next power is supposed to subtract. Okay, so having this, we'll have 2, and then this will give us 5 minus 4, which will give us 2 raised to the power 1. 2 raised to the power 1 is the same as 2. Okay, so that's the first example, which is very simple and straightforward. Okay, another complex one that can be given to us, okay, a very complex one that can be given to us will be to, let me change the color, so example 2. Okay, now with example 2, they are saying that we have a raised to the power 6 divided by a raised to the power 4 is equal to 64. Okay, now with this one, it is not just an expression which involves what? Which involves, someone is just asking a question on the page. I would answer that once I'm done. Okay, so which involves just an expression, which is the first one, but the second one is an equation. Okay, so we'll first of all have to simplify this side of this particular equation, which is this. Okay, good. So let's do that by applying the rule we just looked at. We just looked at basically. We have to identify if the base numbers are the same. Yes, they are. So we just represented with 1 and then 6. What proportion sign is here? Division. So minus 4 equals what? 64. Okay? When we do the subtraction, we get a raised to the power 2 equals 64. Now, they said we should find the value of a. Okay? So if we are finding the value of a and we have a squared is not the same as a. So we would have to get rid of the square. Then that's the second rule I want to talk about. Okay, so in powers of numbers, anytime we have a square, okay, anytime we have a square, so if I have a raised to the power x, okay, and then the a x happens to be equal to 2, so a squared. In order to get rid of the square, I have to apply a square root, which can cancel it. So it's the same thing I'm going to apply here. Okay, so you're going to apply the square root. Now, we don't only apply the square root on the a square. We have to apply it on the 64 because it is an equation. So wherever to keep the equation balanced, whatever you do to one side of the equation, you do to the other side. Okay, so let's look at it. The science students, you realize that you have a dual balance. If I decide to put a square root here, it will tilt to the other side. So I have to put a square root here to keep it balanced. Basically, that's the meaning. That's what we call it, equation, equilibrium. Okay. So we have this one. All we need to do is to just cancel this, and then we'll have a equals root of 64. Now, root of 64 basically means that we want to find out if 64 is perfect square. What are perfect squares? Perfect squares are actually numbers that when you go deep into it, their multiplication is basically the same number multiplying itself. Okay? So what will be the perfect square of 60? Or is 64 a perfect square? Yes. Why is 64 a perfect square? Because two numbers which are the same, when they multiply each other, can result in giving us 64. And those numbers will be 8. Okay? So 8 times 8 equals 64. So the root of 64 is actually what? 8. So our value of a is what? 8. Are we okay? Now let's go deep and take some other ones that we'll have to do a lot to before we can apply this rule to. Remember, the rule says that the base numbers would have to be the same before you can do any addition or subtraction to the powers. Okay, so let's make sure we understand that. Okay. So with that, I said the previous lesson we had in the morning, submit the solutions to the comment section on YouTube. Submit the solutions to the comment section on YouTube. That will make it easy for me to access it. So you just have to go back to my YouTube channel, go back to the videos. That lesson has actually been uploaded. So once you go back to those videos, you see that lesson, and then you post your solutions to that particular lesson under the comment section. I'll check them and give you a feedback as soon as possible. I'll be okay. Awesome. So without wasting time, let's take our next example, which will be example 3. Now, example 3, we want to check this out. 15 raised to the power 9 divided by 15 raised to the power 7. This is so obvious. You realize that the base numbers are the same, so we'll represent it with just a single base number. And then what equation sign is here, it is what? Division. So since it's division, we have the powers would have to subtract. So 9 minus 7, so this will give us 15 raised to the power 2. Now some questions will say evaluate. Once they say evaluate, you don't need to leave your answer in this form. Okay, this form is called index form. So if the question states that leave your answer in an index form, then that is it. But if the question states that you should evaluate, then it means you have to do 15 times or 15 in order to get that particular answer. Are we okay? But if the question said what? Leave in index form, okay? Then it means what? You can leave it as 15 raised to the power 2. Example 2 will be the real, example 4 will be the real deal. Where we want to look at some form of it. So we have 6 raised to the power 2 all divided by 2 raised to the power 2. Okay, so looking at this carefully, we can't do anything to the powers because when we look at this closely, we don't have any number that can change, okay, that can change to let's say we want to use 6. We want to take 6 as our base number. 2 cannot transform itself to 6. Do you get it? And then we want to take our 2 as our base number. 2 cannot transform towards 6 because base number, if you are changing the 6, basically means that we want a number. 2 raised to the power, what number will give us 6? That's the question. 2 raised to the power, which number will give us 6? And we don't really know. Let's find out. 2 times 2 times 2. This 2 times 2 give us 4 times 2, 8. So it means we'll pass 6. Okay, so we can't get any number like that. So when you get a question like this, all you need to do is to just don't overthink it. Expand. Okay? Expanding means just do the normal multiplication. 6 raised to the power 2 means 36. Okay? And then we have 4. Because 2 raised to the power 2 is 4. Then now you can break it down quickly and easy by just doing 4 here, 1, 4 here. Yeah, 9. So we will have 9 as our answer. Okay? Now with this one, we couldn't do anything to the 6 so that it will look like the 4 or to have a base number. Of 2. Okay? We couldn't do anything to it. So all we need to do is to multiply. But there are certain questions that will be given to you that it will be easy for you to transform one to the other. Let's take an example of that. If I have 3 raised to the power 4 times 9, okay? 3 raised to the power 4 times 9. We want to find out. This one we can't do anything to unless we expand. No, that's not true. We can actually do something to it. 9. Can any number or 3 raised to the power a certain number give us 9? Yes, 3 times 3 is 9, which is the same as 3 raised to the power 2. So this 9 can be replaced with this. Okay, so it becomes 3 raised to the power 4 times or 3 raised to the power 2. Now that we know that the base numbers are the same, we just represent it with 1, and then what operation sign is between them, multiplication. So we have 4 minus 2. Sorry, 4 plus 2. And now 4 plus 2 give us 3 raised to the power 6. And voila, we have our answer. Okay, so you have to look at it and find out. You take the smallest base number, okay, and find out if I take the smallest base number, this smallest base number raise to the power to give me the bigger number that is there that is not the same as the small base number. Okay, so let's take another example. If I have, let me see if I can get an example from this book. If I have, if I have 2 raised to the power 2 times 2 raised to the power 2 all over 4 raised to the power 2 times 3 raised to the power 3. So look at it closely. Now, I can have 3 as my base number because I have both of them there. I have 2 as my base number, and here I have 4 as my base number. They are not the same, so you can't really do anything to it. And if you want to go this way too, they are not the same. So rather concentrate on getting the pair which is dividing each other. Okay? So if I want to do this, it means that this is my smallest base number. Let me rewrite this so that you can see well. Okay, so it basically means that the smallest base number is 2. So 2 raised to the power to give us 4. So that we can replace that with what? The 4. Okay, so 2 raised to the power 2 should give us 4. So we are going to replace that with this 4. Okay, remember the 2 is already there. So we maintain it. But it's supposed to be, the operation sign between them and the new square that is coming should be multiplication. Okay, so to rewrite this, we'll have 2 raised to the power 2 times, or 3 raised to the power 2. All over, we are replacing the 4 with the 2 raised to the power 2. So all over 2 raised to the power 2, and then there was a square there already, so raised to the power 2 again, times 3 raised to the power 2. Are we okay? So having this, all we need to do is to, once bracket is there, multiplication, so this will change, and then I will have 2 raised to the power 2 times 3 raised to the power 2, all divided by 2 raised to the power 4 times 3 raised to the power. No, okay, it's 3. Was it 3? It was 3. I made a mistake there. Okay. It was 3. Okay. Yeah, because the original question I wrote was 3. Okay, so raised to the power 3. Now that we have this, we can go ahead. Base number are the same. What is between them? It is what? Division. We'll concentrate on this first, the division, because we can go this way. If we are going this way, that means we are going to be using the multiplication. But we are going what? Vertical. So what's by is the fraction by, and the fraction by is actually division. So we'll do the division first. Okay? So you can quickly do that by writing it as, let me bring this here, by writing it as 2 raised to the power 2 divided by 2 raised to the power 4, and then now this is the equation between them, so we'll bring that, and then we'll do that for the 3's. 3 raised to the power 2 divided by, divided by 3 raised to the power 3. Solving this, we have division, okay, which means subtraction. So 2 minus 4, put that in brackets, and then bring the multiplication. You can decide to ignore this multiplication because brackets actually means multiplication, okay? So having that, we'll have 3. The base numbers are the same, so 2 minus 3. Okay, let's solve this. Solving this basically is going to be, we have 2 C's, we owe 4 C's, so 2 raised to the power negative 2. And then times 3 raised to the power negative 1. Okay, that brings me to the next rule I want us to talk about. That's the main reason why we are having this lesson. I want to explain that rule into details, because if you are going to bring anything that is going to be haunting or daunting to you, it's basically this particular rule I'm about to talk about. But before I talk about that rule, please don't forget to subscribe. If you've not liked this lesson, like it right now, and then try and share the link to your family and friends so they can also benefit and enjoy from this online lesson. So without wasting time, this is actually going to be our final answer, unless of course maybe they decide that you should do something to it. But you can go further, and the extra thing you can do about it, let's look at the rule I'm about to talk about, then when I'm done we'll come back to it and look at how we can go further to simplify this. Okay, so let's move to the next screen. Now the next screen, I'll talk about a rule. Okay, And that will involves negative powers, okay? So if I have maybe 8 raised to the power negative 1, what does it mean? It basically means that this is 1 over 8 raised to the power 1, okay? Let me explain this. If I have 1 over ax, okay? I saw this in an equation. I don't want to use 1 over ax, which is a fraction. We always want to avoid a fraction in equations. So that's why I can look for LCM and then we remove the denominators and do all those gimmicks to it. But with this one, what it means is that because it is a power and then it is over 1, when we change it, we want to get rid of the fraction from this. It basically means it's going to be a raised to the power negative what? X. So this means that the over 1 is now changed to the negative power. Okay? What do I mean by that? If I have 1 over p squared, it means that what? I want to get rid of the what? The 1, the numerator. And now I'll not have a denominator or a numerator. I'll not have a fraction. So basically it's going to be p raised to the power something. Now to get rid of this whole fraction thing, I can do that by basically writing this and then making sure my power is a negative. That's what it means. Okay? So doing this, all we need to do is basically go forward and take some examples. So if I have maybe 1 over, let's see, 27, okay? And then they are saying solve this in an index form. It's 1 over, okay? 27, we want to look for the square of that. So it's going to be 3 raised to the power 3, because 3 times 3, 9 times 3, 27. So 3 raised to the power 3. And then we'll have 3. We want to get rid of this, okay? So we just have to negate the power, raised to the power negative 3. Okay, how relevant is this? This becomes very relevant when you are solving certain questions, and we want to look at those questions now, okay? So the very first example to that question will be, I have 1 over 9x equals 9x equals, let me see, 81. So having this, look at where the x is. He said I should find the value of what? X. Look at where the x is. Let me find the value of x. Okay? He said I should find the value of x. I am not going to do that. Okay? When the equation is in this state, I will not do that. So first of all, what I have to do is that change and make sure I get rid of this 1 over whatever. Okay, so I'm going to get rid of that. How do I get rid of that? It's just by bringing the 9 up and then negating the x. And then this will give us 81. Okay, now to go further to find the value of what? X. All I need to do, make sure is that the base numbers are the same. And how do I get the base numbers to be the same? I get the base numbers to be the same by basically looking at the other number. Okay, it is 81. Then I come back to this smaller base number and find out this smaller base number raised to the power what is going to give me this big number. 99, obviously 81. So it means that 9 raised to the power. Okay, that's not going to be 9 raised to the power. So it's going to be 9 raised to the power 2. Okay, 9 raised to the power 2, because 9 raised to the power 2 means 9, 81. Okay, so this is 9 raised to the power 2. So now these base numbers are no longer needed. So what we'll do is that we're going to cross them out, and I will have x. Remember, you are not done. It says you find the value of x, not the value of negative x. Okay? So all you need to do is to divide both sides by negative what? 1. Okay? Because we want to get rid of the negative. So we cancel. When we cancel, and that's the only thing we cancel. In the raised to the power 1 is the same thing. So it becomes x equals what? 2 over negative 1. Remember, denominators are not supposed to carry a negative. So we only put the negative to the 2. So x equals negative 2 over 1. And anything over 1 is that same thing. So x equals negative 2. So this will bring us to the end of this lesson. We are going to continue within the week. So please ensure that you subscribe to the channel and then click on that bell icon so that anytime within the week when I come online, you get a notification and then you join me. You might not be privileged to have the information that will come online, whether tomorrow or Friday or Saturday. So subscribe and then click on that notification bell, and then we'll talk. Okay, so enjoy your evening. This is a very short class. Enjoy your evening. I can't promise that I'll be online tomorrow, but let's see, God willing. If I'm online, you should know about it by just subscribing and hitting on that notification bell. Okay, don't forget to subscribe to the channel. Don't forget to like, comment, and if you have any issue, post in the comment section and I'll get back to you. Those who want to find out about the submission of the previous trial work, I told you to submit it in the comment section. Okay, so have a nice day and then have a nice evening. Don't forget to pray before you sleep. Bye.